All right, it's doing it again. I'm getting kind of nervous. Maybe it's the flash drive. I wonder if I need to get a new one. All right, so let's go through these answers again. Geometry, welcome to 6.2. Relate transformations and similarity. I can identify similar transformations called dilations. So we're going to complete our scale drawings with this section, okay? And I can find a dimension of a scale drawing. So here we go. Given, triangle RST is similar to XYZ. So remember I told you if it's similar, the angles are the same, but the sides are proportional. So they write two of the sides, RS over XY, and then ST over YZ, is 3/2. Well, find RT over XZ. It's going to be the same, 3/2. All the sides have to have the same ratio. So you can write this way or this way, 3:2. Okay, number 2. Given triangle EFG is similar to triangle MNP, and the ratio of size is 2:1. So FG is from the first triangle, so we're going to write 2 over 1 equals 4.5 over x, cross multiply and solve. 2x equals 4.5, divide both sides by 2, you get 2.25. If you need to pause that, go ahead. Alright, so here we go. Key vocabulary. A dilation is a transformation that preserves angle measure. Okay, so the angles are congruent. And the results of an image with the lengths proportional, so the sides are proportional to the pre-image lengths. The ratio of lengths of the corresponding sides of the image and the pre-image is called a scale factor of the dilation. Dilations can also be called similarity transformations. Okay? So, for instance, you can see the original blue is transformed onto the purple. This is going to have a scale factor that becomes larger. Now, normally, when we've been writing scale factor, whatever the side length was for the first triangle compared to the side length of the second triangle, that's fine and dandy. But when we start kind of relating it more towards dilation, since this is getting larger, just make sure the value is greater than 1. If we went from this purple triangle to the blue one, make it less than 1 because it's getting smaller. But we're starting with this one. Okay, this is A prime, B prime, C prime. That little slash mark is a prime. Okay, now, example 1. Okay, I might as well just move this here. So, in the diagram we have triangle ABC, so I wrote it right here, and triangle DEC, put it right here. Now be careful, this whole length, that's x plus 15, okay, compares to 15. The 11 is going to compare to 7. So, the description. This is a dilation with the center C. Okay, now normally we would say the scale factor is from 11 to 7, because 11 was from our larger triangle, 7's our smaller one. But if I want to know the actual dilation, you know, this is fine. But when I want to know the dilation, it's getting smaller. So make sure you write it as 7 over 11. It's a shrink. Okay, so 7 over 11 is less than 1. Now let's find x. Okay, so 11 compares to 7. X plus 15 compares to 15. So I have 11 over 7 equals x plus 15 over 15. Cross multiply. I have 7 times that quantity, x plus 15. 11 times 15 is 165. Remember how to multiply 2-digit numbers by 11? Take these two, 1 and 5, put on the outside, add them up. That's the middle number. Distribute. 7x plus 105 equals 165. Subtract 105 on both sides. 7x equals 60. Divide by 7. I know it's not a pretty number, but it still works. Alright, we're still recording this time. Alrighty, here we go. Back side of the page. Alright, more key concept. Combining dilations and rigid motions. Okay, so sometimes you might make it smaller and then flip it over. So if a dilation followed by any combination of rigid motions can be used to move one figure onto another, the two figures are still similar, okay? Because these two will be congruent. These two are similar. So triangle ABC is similar to DEF, okay? So obviously that is like a dilation. And DEF is congruent to let's see here, DEF, GHJ. Oh, I found a little error here. Nobody saw it. So that means these two are also going to be similar. Okay, so put a J right here. Yeah, so this is a dilation. It's getting smaller, and then we've reflected over the y-axis. All right, so triangle ABC and FGE are similar. Describe a combination transformation that moves ABC onto FGE. Okay, so let's see here. Dilation with center A. Okay, so this is the center A. And a scale factor. Okay, let's go to the scale factor. So the small length is 30, but this large length is 50. So it's 3 to 5. Okay, from small to the big. Moves triangle ABC onto ADE. Okay, so ADE, the whole big one. And then we reflect this. Then a reflection moves triangle ADE onto triangle FGE. Okay, so that's more of a precise description of that answer. I would be satisfied if we say it's a dilation with the scale factor, and then you reflect it. That's good enough for me. Okay. Use transformations to explain why pentagons EFGHD, so that's EFGHD, and RSTUV are not similar. RSTUV are not similar. Okay, let's see here. First of all, I'm going to do the ratio of sides. Okay, start with EF, goes to RS, FG, goes to ST, GH, goes to TU, HD, goes to UV, and DE goes to VR. So I hope you understand where this is going. Now we got to find all the ratios of the sides, reduce them to see if they're going to equal the same thing. So EF is 14, RS is 28, FG is 15, ST is 30, then I have 14 over 28. So far, double it, double it, double it. Okay, HD is 16 over 32, and then 10 over 20. Okay, let's see here. The sides are proportional, but the angles are not congruent. Okay, so let's see why. Angle E, does that correspond to angle R? Yeah, they're both 90. The rest of them we cannot see. It's hard to tell. Okay, I have this. It says per the book. So obviously I have this problem from the book. I wonder why. It's hard to tell for the angles because we don't know them. But we don't know the angles. All right, so I'm going with it. To me, they are similar. It's hard to tell. We need more information. Okay, moving on. Shown as Sierpinski's triangle, what can you say about the transformations used? Well, you start with the triangle. Then you find the midpoint of each side and connect. Then find the midpoints again. And then find them again. What's happening? What can you tell me about all these triangles? You keep connecting the midpoint. Okay, so basically there's a scale factor from 2 to 1. Or you can say they're getting smaller, the dilation. You can say hi, Blaze?
Hi.
is 1/2. So each triangle is going to be half. So this large one, basically each segment like this half, and then half, etc. All right, so here's our homework assignment, and there's our standard. Everyone have a nice evening.